Part B then of question 10, we need to find the maximum value of V, showing that the value you have found, so we'll need to find that value, is a maximum value. We've got our equation here, it's a cubic, here it is just above from the preceding part of the question. So we need to show it's a maximum, so let's do dv dx then. Differentiate, the 3 comes down to be with the 4 to make 12, x to the 1 less, which is 2. Move along to the next term, the 2 with the 26 makes minus 50, 2 lots of x to the 1 less, which is 1. And then the x differentiates to 1, and we've got 40 lots of 1, which is 40. So there's dv dx. We can usually don't write power 1, so we'll just get rid of that. Now, dv dx, maximum value, we need the turning point, equals 0. Notice there's a 4 common, so I can take that outside a bracket, and we'll have 3x squared gives you the 12. This will 26 and then 13, so this will be minus 13, won't it? Times 4 will give you the 52, and then plus the 10. So hopefully we can factorize this. Let's have a go here. So you've got 3x squared, well it's obviously going to be 3 and 1, because there's no other choices that we can have when we do the first when we look at it initially. The 10 can be 10 and 1, or 1 and 10, or it could also be 5 and 2. Now, if I look at that, 3 ones are 3 and 10 ones are 10, and they add up to 13. So a 10 and a 1 looks promising. So let's try that. So you've got 3x squared, then I'll need a minus and a minus. Okay, that doesn't look too bad. Now I can just double check it. So let's just double check it then. 3x squared, yeah. Minus 3x minus 10x, which is minus 13x when you add them. And then the last term, minus 10 times minus 1. Minus times a minus is a plus, 10 ones are 10. So everything seems fine. So that tells you then that 3x minus 10 equals 0, or x minus 1 equals 0 for the product to equal 0. Now I'm going to do this in one fell swoop. Move the 10 over. So the 10 comes over here, and at the same, after I've done that, then I'm going to move the 3 from times to divide, 10 thirds. And this one, all you have to do here is just move that 1 over, flips the sign to a 1. So these are the two possibilities. But what did we say in the question? X had to be less than 2.5. So x equals 1 is the only value we're allowed. Now, what value is v when we have that? Here's our v. Put 1 in. 4x cubed minus 26x squared plus 40x. Here, v equals 4x cubed. What was it? Minus 26x squared plus 40x. And our input value is 1. So the volume, 4. 1 cubed is 1, so that's just 4. 1 squared is 1, so that's just minus 26. And 40 times 1 is 40. 40 take 26 is 14, plus another 4 is 18. So we've got 18. The question is in meters, everything's in meters, so we better put the units in at the end. 18 meters cubed. Now, is it a max or min volume? We've found out a volume, a potential max or min volume, but we still haven't worked out whether it's a max or min. So we need to differentiate to get the second derivative, yeah? So this will differentiate to 24x, and this will go to 1, so that'll be minus 52, and this will go to nothing. So we can write that down just by looking at this first derivative. Now, d2v, because we're differentiating v, by dx squared. And what was it? It was 12x squared, so that went to 24x. And then the next term was 52x, and that goes to minus 52, because it was minus 52x. Equals, now put the 1 in. Now at x equals 1, d2v by dx squared will equal 24 lots of 1 minus 52. 24, take 52 is minus 28, which is negative. So a max at x equals 1. So we've shown it to be verified that it is a maximum. We've verified the volume, and it happens when we cut out a square of 1 unit from the corners. Okay, that's 10b done. Good, that's these questions done then. So I hope you got something from it, from these questions, and enjoyed some of them at least. And hopefully I'll catch you in another set of questions. Cheers.